Hello dear friends, welcome to the lecture of numerical methods. We are studying interpolation, and in the last lecture we have defined the differences: forward difference operator, backward difference operator and central difference operator we have seen in the last lecture. Now in this lecture we will study some more operators and symbolic relation between these operators. What is the relation between these different operators? And also we shall see the method of separation of symbols to use to prove some results. I have written the definitions which are very easy to understand. We will see the meaning of these definitions first, and then we will solve or we will prove the results on this. The averaging operator mu. Earlier which operators we have studied, that is delta, forward difference operator we have studied, and then del, backward difference operator we have studied, and delta, small delta, that is central difference operator we have studied. These three operators we have studied earlier. Now here we are going to study averaging operator mu, and that is defined by this equation. So it is averaging operator, the symbol is mu, and its definition is mu of yr. R may be any value, say from 0 to n, and mu of yr is equal to half yr plus half plus yr minus half. So these values are added, its average is taken. So that's why it is called averaging operator. Average of yr plus half and yr minus half at these values of y, its average is taken, so it is mu of yr. And so we should remember this as a definition for mu. Mu of yr is half of yr plus half plus yr minus half. Next operator is shift operator, that is E. It is denoted by E and defined by the equation E of yr is equal to yr plus 1. Why it is called shift operator? It shifts the value to next immediate value. That is E of yr is yr plus 1. Here the difference is assumed to be 1. So that means if you consider E of y1, then it will be E y1 plus 1, that is y2. Next value yr plus 1. E of y1 is y2, E of y0 is y1, etc. And what will be the higher order operator? E square yr, that will be E of yr, and that is E of yr is yr plus 2, and this is E of yr plus 1 is yr plus 2, next value, and thus we have E square yr is equal to yr plus 2. That means when we consider the shift operator in this powers, then there will be addition of this power of E and suffix of y, r plus 2, or in general the relation is e to the power n of yr is y r plus n. So this is also important and we have to remember it. E to the power n yr is yr plus n, or that means this is true for a positive n and negative n or fractional n also. So we have, say, e to the power 4 of y3. This will be y4 plus 3, that is y7 from this. And similar to this, we will have e to the power minus 2 of y3. So this will be sum of these two, minus 2 plus 3, that is y1, by this relation. So this is the shift operator. And now the relationship between delta and E. So that is the operators. This is forward difference operator and this is shift operator. And we know delta of y0. Delta of y0 we have defined last lecture, y1 minus y0. And this y1 can be written as E of y0 by definition. So this is 1 power and 1 plus 0 is y1. So E of y0, or by this definition, r is 0. Therefore E of y0 is y0 plus 1, that is y0. And E of y0 minus y0, the same. And here y0 can be taken common. and the in bracket remains e minus 1. So this is simple relation, that is delta of y naught is equal to e minus 1 of y naught, and y naught can be changed. So the equivalence relation we will obtain is delta is equal to e minus 1, or delta is equivalent to e minus 1. So this is the relation actually between delta and e minus 1, or we have to remember this. It is one and the same. This e is written as 1 plus delta. So this is relationship between delta and e. Now how this relation is important or useful, that we will see. Delta of e minus 1. So if you want to find the third order difference, forward difference of y naught, we have obtained this in the last lecture. So this can be obtained using the relation. So this delta, we can write this as e minus 1 cube on y naught, and this can be expanded. So what is e minus 1 cube? We have e cube minus 3 e square and plus 3e and minus 1 over y naught by cubic expansion of this. And this is, what is e cube y naught? That is y3, sum of power and this suffix. So using this relation, en yr, that is yr plus n. So e cube y naught is y3 minus 3 e square y naught is y2, and further this is 3 e y naught, e of y naught is y1 minus y naught. So this is the relation that we have seen earlier, delta cube y naught. And thus it is easy to obtain these higher order differences, forward differences or backward differences using the shift operator e. Now these are some relations between delta, these operators. Here this is backward operator del. Del is 1 minus e to the power minus 1. Delta is e to the power half minus e to the power negative half, and so on. So we shall prove these relations one by one. Few relations we will prove, and remaining you can try. Now see the first one. So this also we have to remember, these two operators that I shall write here. So the operator mu of yr is half, y of r plus half plus y at r minus half, and e power n of yr is equal to y r plus n. And relation between delta and e, delta is equal to e minus 1 or e is equal to 1 plus delta. So these are the relations we have. Now we will prove these relations using these relationship between the operators. First, and the proof for the first, this we will solve after considering these. And first proof for first. See del, this is del, we know del operator on y1 we have by definition. Del y1 is equal to, this is y naught minus y1, and this we can write in terms of y1. Y naught can be written as e power minus 1 of y1. See how it is written, e power minus 1 of y1. Now you see, using this e power n yr, that is yr plus n, and this will be the addition, minus 1 plus 1 is 0, that is y naught, and minus, we keep y1 as it is because we want the same value of y on both sides, so that can be written common. It is operated on the same value of y, then there will be the equality of the operators. So this is a del is operated on y1 and e power minus 1 operated on y1, and there is 1 only on y1, and we can take this y1 common. and this must be written on the right second factor or right factor. So this is e power minus 1 over y1. And now equating this first and the last, see this both are operated on y1, so this del is equivalent to e power minus 1. So thus see, this is not correct, we have written, this is wrong. What is del y1? It is actually y1 minus y0. We have written delta, it is y1 minus y0. And now y1 we should keep as it is, so this is y1, and y0 we should write y1 minus y0 we should write e power minus 1 of y1. Now you see, this is y1 minus y0, y1 is as it is, and this we are y0 we are changing because we have y1 on left side, so the right side should be written in terms of y1, and that now we can take y1 common, 1 minus e power minus 1 on y1, and now the equating the first and the last we get the relation. So this implies, or this gives del is equal to 1 minus e power minus 1. That is the first result. This is the first result. So it is easy to obtain these results. Now the second we consider delta. So delta definition is here. See, delta we have defined earlier, not here, but earlier we have delta y half is equal to y1 minus y0. This we have defined. This is the definition of delta, and that this y1 can be written in terms of again e. So we should write this as, so we want to write this in terms of delta half. See, the y half in terms of half. We have to write these y1 and y0 in terms of half, and for that purpose we use the shift operator. So this y1 I shall write e power half y half, because the sum of these two is 1. So this is important. E power n of yr is y of r plus n, sum of these two, and thus to write it in terms of both we have to write in terms of half. So first y1 I have written e to the power half y half. Now how will you write the second in terms of again half, that is y half. What should be the power of e, so that the sum of these two is 0, and for that purpose we must write here negative half. So negative half, positive half becomes 0, and thus now we have y half on both left side and right side, and now that can be taken common. So in bracket what remains, e to the power half minus e to the power negative half of y2, and the left side is also not y2 but half, y half, and the left side is delta y half. Now thus these two are equal, and this implies delta is equal to e to the power half minus e to the power negative half. So that is the use of the operator, shift operator e, that is very useful, and thus we have written in terms of e. Now this is easy, you should try. So use this definition and write this in terms of e, this in terms of e, and that easily you will get the third result. So third, try yourself. Now we will consider the fourth one. Fourth result, that is mu square is equal to 1 plus. Third is easy, use this mu definition of mu, you will get it easily. So for fourth result, it is mu square is equal to 1 plus 1 by 4 delta square, and we have to use this relation. We have mu is equal to half in bracket e power half plus e to the power negative half, and therefore what will be mu square? Mu square will be square of this, which is 1 by 4 and e to the power half plus e to the power negative half whole square. Now that can be expanded, and a plus b whole square formula we can use. Square of this means only e. and middle term is twice. Product of these two is 1. So middle term is only 2, and the square of the third term is again e to the power negative 1. So this can be written as 1 by 4. Now we want to write it in terms of delta, and delta is e to the power half minus e to the power negative half. We want delta in right side. So for that purpose we will write e to the power half minus e to the power negative half whole square, and we must add 4. Now it is easy to verify this. This is the same. So what is the e power? There is positive sign, here is negative sign. If you take the negative sign, the middle term will be minus 2, expansion of this minus 2, and that minus 2, this plus 2 gives again plus 2. So you can expand and verify this, and therefore this is 1 by 4. What is this is a delta square. This value is delta by 2 and plus 4 by second, and that is same as 1 by 4 plus 1 is 1 plus half 1 by 4 times delta square. This is mu square, and therefore what will be mu? Mu will be under root of this. So this gives the fourth result. Fifth is also easy, and you should try fifth. So fifth, try yourself. Now how will you solve the fifth one? You prove right side to left side. Prove del E is equal to delta, and delta e power half is equal to delta. So that you should take this on y naught. Take this del E of y naught and simplify similar to this. So you try yourself this. So thus we have proved these results. Now there is another operator. Further next we define an operator capital D, which is actually derivative operator, d by d of y x is equal to d by dx of yx, or this means that is d is equal to derivative with respect to x. This operator we have defined, and this is further operator capital D. Now we have by Taylor's series. Taylor series expansion of function y of x plus h. Actually that theorem we have written in terms of f of x plus h. Here we will write it as y of x plus h. So it is y of x plus h, and that can be written as y of x. Right side is y of x plus h into y dash of x plus h square by 2 factorial y double dash at x plus h cube by 3 factorial third derivative of y and plus so on. So this is the Taylor's series that we have studied earlier, and y of x plus h, now that can be written in terms of shift operator. So this can be written as e of yx, that is this shifts the value of y of x to y of x plus h. So what is e operator, e of yr, that is yr plus 1 we have written, here it is h, the difference is h. So therefore e of yr is yr plus h, and that means e of yx is yx plus h. It is the next value. The difference is assumed to be h, and earlier we have assumed the difference as 1. So e of yx is equal to, now here this can be written as yx and h of yx as d of yx. So d means derivative. So this is yx plus h dyx plus h square by 2 factorial. This will be d square yx, second order derivative, and plus h cube by 3 factorial. This will be d cube of yx, and plus so on. Now we can take y of x common on the right side. From the right side we can have common it is, and then this can be written as e of yx is equal to, the right side I shall write in bracket 1 plus, this is hd, this is h square by 2 factorial d square, or h square d square by 2 factorial, plus h cube d cube divided by 3 factorial, and plus so on, operated on y of x. Y of x is taken common and we have obtained this. So now it is e on y of x and this on y of x, means e is equal to this expression. But what is this expression? This is exactly e to the power hd of y of x. Exponential series. We have exponential function e of x is 1 plus x square by 2 factorial plus etc. And in place of x, here it is hd. So this is e power hd of yx, and thus this gives the relation e is equal to, capital E is equal to small e to the power hd. So this gives e is equal to e power h into d, where d is the derivative operator, h is the difference in the values of x. So thus we have obtained a few relations between these operators, and these are easy to understand, but we have to remember this. And now there is a method of separation of these symbols. Operators means symbols, and using these relations between e and delta etc. So we have to prove certain results, and there are 2 examples I have written here. We shall prove this. Now first is delta raised to n ux minus n is equal to ux minus 1 plus etc. n, and with this identity is, this relation is to be proved. We will consider its right side, and we will prove right side is equal to left side. Solution for first. LHS is ux. In place of y, here u is used. The variable is u. N x minus 1, value of u at x minus 1, plus n into n minus 1 divided by 2 factorial u x minus 2, and this is continued, plus minus 1 to the power n u x minus n. And now this we can write in terms of shift operator e. So this I shall keep as it is, ux minus n, and this I shall write in terms of ux. So what should be the power of e? What should be the power of e? We have the relation as e power n of yr is equal to yr plus n, sum of these two, and the sum of these two must be x minus 1. So this must be minus 1. E power minus 1 of ux, that is ux minus 1, plus next n minus 1, n into n minus 1 divided by 2 factorial, and likewise this is to be written in terms of ux e power. Now the power of e must be minus 2, so that this will be ux minus 2, and so on, plus minus 1 to the power n, and this must also be written in terms of ux. Ux we want to take it as common, and therefore we are expressing each term in terms of ux, and thus here the power of e must be minus n. So this you should note how we have expressed each term in terms of ux using the shift operator. The powers are taken as negative because these are negative numbers. If it is positive, then the power will be positive. And thus this now ux is to be taken common. So 1 remains here, minus n into e power minus 1 plus n into n minus 1 divided by 2 factorial e power minus 2 and plus so on. And last is minus 1 to the power n e power minus n. And this is operated on ux. This must be written here only. Why not on the next line? Because this is a operator and this must be operated on ux. And remember, ux must be written as the second factor in the product or last factor in the product or post factor. This must be a post factor. We can't write ux earlier, it will be meaningless. So because it is, all these are operated on ux. And now what is the bracket? Now you can observe these are the binomial coefficients, minus n into n minus 1 divided by 2 factorial. Next will be n into n minus 1 into n minus 2 divided by 3 factorial and so on. So this is a binomial expansion. But binomial expansion of what? 1 minus e to the power minus 1 raised to n of ux. This is the binomial expansion because binomial theorem is, see, 1 minus b to the power n is equal to 1 minus nb plus alternate sign plus minus n minus 1 divided by 2 factorial b square, etc. So this is using this result. Now you can say what is b? B is e power minus 1 and therefore nb is n into e power minus 1. B square is square of e power minus 1, that is e to the power minus 1 and so on. So thus this result is used. And now this further is equal to 1 minus e power minus 1 is 1 over e of ux. And next this can be further simplified as this is equal to, we subtract this and that gives e minus 1 divided by e to the power n is there. So it should be corrected. So this must be 1 minus 1 by e raised to the power n, and that is e minus 1 divided by e raised to the power n over ux. And that is, what is e minus 1? We have seen that delta is equal to e minus 1. This is the value of delta divided by e to the power n of ux. Since e minus 1 is equal to delta, and that will be delta power n e power negative n on ux. See, it is at the denominator, and this is equal to delta power n. And what is this? This is u of x minus n using the relation, and this is what is the left side. So thus this proves the result is equal to LHS, and thus this completes the result. Now what about the second result? Second result I shall leave you to solve. Now try yourself as for second result. So how will you try for solution for second? Prove LHS. LHS is equal to RHS, and for that purpose you write this as LHS, and we may see we can take u0 common, that is easy. So this will be e power x and take u0 common, and then what remains will be 1 plus x delta plus x square delta square divided by 2. That is exponential series. We have done this in earlier result, and that will be in terms of exponential series, so which will be 1 plus x delta etc. So you verify this is e power x, this is e to the power x delta on u naught. You should write the entire steps. I have written in short, and again this can be written as e power x is common 1 plus delta of u naught. And then what is 1 plus delta? You see 1 plus delta will be e, and that is e power x into e of u naught. Again write the expansion of this e power x into e, and that is 1 plus x e plus etc. x square e square divided by 2 factorial etc. Operate on u naught, and then you will get this result. So please try the second problem yourself. So remaining part we will continue next time. Thank you.